Okay, the very next thing that we're going to do here is we are going to balance this redox reaction, but this time we're going to balance it in a basic solution, which just means we have a couple extra steps just to neutralize it a little bit. So first things first, you want to write your two half reactions. So I already wrote them down. I have manganese right here, so that's one of my half reactions. I have bromine right here, so that's my other half reaction. And so just like the acidic solution, most of these steps are going to be the same, where you're going to balance other atoms, then you're going to go to oxygen, then you go to hydrogen, then you go to the electrons. The only difference is then we're going to have to do this neutralization step, so I'll explain when we get there. But let's start by balancing manganese. I got one on the left, one on the right, we're good. Bromine, I got one on the left, one on the right, we're good. Now we want to go to oxygen, and the way you balance oxygen is by adding in water. So if I have 4 oxygens on the left, 2 on the right, that means I need 2 waters. In the second reaction, I have 3 oxygens on the right, so that means I need 3 waters on the left. And so now that we added in all those water molecules, we don't have a balanced hydrogen. So what we're going to do is we're going to balance hydrogen by adding in some H plus molecules. I got 4 H pluses on the right, so I'm going to add 4 H pluses on the left. Down here, I got 6 hydrogens on the left, so I'm going to add 6 H pluses on the right. And so now that we balanced our other atoms, we balanced oxygen, we balanced hydrogen, now we're going to balance charge. So I need to figure out what the net charge is on each sides of my reactions. This first one, I don't have any charges over here, but over here I have a positive 4 minus 1. So I have a total net charge of positive 3. So I need to turn that positive 3 into 0. So the only way I can do that is by adding electrons. So I'm going to add in 3 electrons to cancel out all these charges and get 0 onto both sides. For my second reaction, I have a negative 1 charge right here. Then I have a positive 6 charge. So that's positive 6. And I have a negative 1. So I have a positive 5 right here. So I need to add in electrons to change this positive 5 to a negative 1. So what that means is I'm going to add 6 electrons to the right-hand side, because 6 electrons plus positive 5 is going to give us that negative 1 value. Okay, so now that we're here, what we can do is we can start our neutralization step. So what that means is anywhere I see an H+, I'm going to neutralize it with hydroxide. Hydroxide is what makes it basic. So because I have 4 H+, I'm going to add 4 OH- to the left, but what I do to the left-hand side, I have to do to the right-hand side. In my second reaction, I have 6 H+ on the right, so that means I'm going to add 6 OHs to the right, but I have to do the same thing to the left-hand side. So that's the first step in neutralization. The next step in neutralization is anywhere you see an H+ and an OH on the same side, you're going to combine those two molecules together to form water. So what I mean by that is I have 4 hydroxides, 4 H+, so that means in my first half reaction I have 4 waters now on the left-hand side, and then I'll just carry down everything else. In my bottom reaction, I don't have any H+ and OHs over here, just OHs, so we can ignore that. On the right-hand side, I have 6 H+ and 6 OHs. So we're going to combine those molecules together, and we're going to have 6 waters on the right-hand side. So I'm going to carry down everything else. And we're left with this. So at this step, what you want to do is you want to look at each half reaction individually, and you'll notice I have water right here and I have water right here. So because I have water on both sides of the equation, we're going to cancel some stuff out. So what's going to happen is both of these waters are going to cancel out, So we're left with 2 of these. In the bottom reaction, I have 6 waters over here and I have 3 over here. So these 2 are going to cancel out. And so that means I am left with 3 waters right there. So now that we simplified, now we have to match basically our electrons again. And so we're going to multiply both reactions by the same number to make them match. So I'm going to multiply this top reaction by 2 so I can change my electrons to be 6. So this reaction is going to be 4 waters plus 6 electrons plus 2 MnO4 minuses turns into 2 MnO2s plus 8 OH minuses. And so now what we're going to do, just like we would do in math class, we're going to add these reactions together and we're going to eliminate anything that we see on both sides. So the very first thing that you can eliminate is your electrons. You did that on purpose. The next thing that we can eliminate is some of these waters. I have 3 over here, but I have 4 over here, so all of these waters now go away, and that turns into a 1. Then the next thing that I have in common is I have hydroxide, so all of these hydroxides are going to go away, and I'm left with 2 right there. So my final reaction becomes H2O plus Br minus plus 2 MnO4s turns into BrO3 minus plus 2 MnO2s plus 2 OH minuses. Oops. And so from there, what you want to do is you want to check the total net charge. So I have -1 plus 2 -1s, so that's -2. So I have a total of -3 on the left-hand side. In my other reaction, I have a -1 plus 2 -1s, so that's -2, so I have -3. So that means we are all balanced.